Alright, this is lesson 21 for Algebra 2. We're going to be solving quadratics when a is equal to 1. And our goal is to solve quadratics. Yesterday was a hard lesson because we had to learn how to graph, right? And graphing is something that you need to know how to do in any instance. And the best way to think about it is always make a table. But again, what we learned is graphing quadratic equations, which means we graphed something that looked like this yesterday. And then the goal was to find the solutions. Can someone tell me, how did I find a solution yesterday from a graph? What's that? When it crosses the y-axis? Is that what it did say?
Yeah.
Oh, okay. Is that when it crosses? Is that what the solution is?
No.
No. It's supposed to be the x-axis. My bad. Okay. So, crosses the x-axis, okay? Crosses the x-axis, right? So over here we have how many solutions? Two, right? So there's one that's right here and here. So we got x is equal to 1 and x is equal to 4, right? Does that make sense? Okay. This was hard, right? We had to graph last night. Took a lot of work. It's kind of tedious. Today what we're going to do is we're going to find the solutions algebraically without doing all this extra work, okay? Okay. You still need to know how to graph. It's just we're going to find a faster way to find these two answers, okay? So here are the steps for today. We're going to make one side equal to 0, factor the opposite side using Xbox, and solve each factor using the zero product property. Okay? So if you're on the video, pause it, write this down. I'm going to move on right now. Okay? And we're going to also focus on this term called the zero product property. Raise your hand if you've heard of this before from a previous class. Okay. If you haven't, this is a shortcut we're going to use, and I'll show you on number 1. Number 1 will look very complicated, and then we're going to simplify it by using this property here. Okay? Here we go. Number 1. X squared minus 7x plus 12 is equal to 0. Sometimes you're going to see the original problem with a y at the beginning, right? So whenever there's a y, all you got to do is take the y and turn it into a 0. Okay? I want to make sure everything's on the left-hand side, so what I'm going to first do is make sure everything's on the left. We have x squared minus 7x plus 12 is equal to 0. Okay, so it's there. I'm going to check for a GCF. I'm going to factor a GCF. There isn't a GCF right now, so I'm going to identify my A, B, and C. And then I'm going to create an X box, putting 1 and 1 as A times C is 12, B is negative 7. Okay? Factors that multiply to the 12 that add up to negative 7 are negative 3 and negative 4. So I'm going to box these. Right? We already know how to do this. And I'm going to rewrite my equation as x minus 3 times x minus 4 is all equal to 0. Okay? Now we know that there are two answers here because we have an x minus 3 times x minus 4. There are two x's, right? In the original problem, the largest exponent is x squared, so there's got to be two answers, right? So I have to ask myself, how do I get these by themselves? Both of these binomials have a multiply sign in between them, so I have to figure out how to separate them. So the only way I could do that is the opposite of multiply, which is divide. I'm going to divide one of these, okay? So I'm going to divide both sides by x minus 4 because I'm going to focus on this x minus 3 and isolating it. So I'm going to divide both sides by x minus 4. And when I do that, these two cancel out, and 0 divided by anything is still 0, right? So we have x minus 3 is equal to 0. Add 3 to both sides. So x is equal to 3, right? But how many solutions am I supposed to have? 2, right? So I'm going to rewrite this step here that I had, bringing it across again. Okay, I'm going to divide both sides by, this time not by x minus 4, but by x minus 3. And when I do that, both of these cancel out, so I have x minus 4 is equal to 0 divided by x minus 3 is still 0. Okay, add 4 to both sides, and we get x is equal to 4. Okay, kind of a lot of busy work here, right? You see all this extra work dividing. You see that, and we have two answers. Well, someone said, let's just use this property called the zero product property. When we're at this step here, we're just going to jump straight to the answer. So check this out. The zero product property, what you do is when you're at the step of two binomials together, So when we were at x minus 3 times x minus 4 all equal to 0, you're going to take each of your binomials. This is how we're going to apply it. Each of your binomials, x minus 3 is equal to 0, and x minus 4 is equal to 0. That's what we're going to do. Instead of doing all this extra work, we're just going to jump from here to here. You see that? Okay. And then we still solve, and you get your two answers. Adding 3 to both sides here, x is equal to 3. Add 4 to both sides on the second one, you get x is equal to 4. So you don't need to worry about all that extra work we just had, okay? All we need to worry about is the zero product property. Does that make sense? Questions on number 1. Okay, I'm going to show you one more time number 2. Number 2, on number 2, we have a trinomial equal to negative 4. We don't like this negative 4 on one side. We want to move everything over to one side. So I'm going to add 4 to both sides first because we want to make sure everything is together before I start working out my... Oh, there's the answer. Before I start working out my x box, okay? We know that x squared is the largest exponent, so there has to be 2 answers here. It's all together on one side, so I'm going to do my x box now. So we got 1 and 1. We have 9 and negative 6, right? 1 times 9 is 9. We're trying to find factors that multiply to positive 9 but add up to negative 6. Which are my 2 factors? Negative 3 and negative 3, right? Box these. I can't simplify them anymore, so now I'm going to rewrite my trinomial as x minus 3 times x minus 3 is equal to 0, okay? Instead of doing all that work, I can use the zero product property now, making each of these 2 separate equations. X minus 3 is equal to 0, and x minus 3 is equal to 0. Add 3 to both sides on each of them, and I get the same answer twice. So how many answers are there really on this one? Just 1. It just shows up twice, okay? So you would just write x is equal to 3 as the answer. Even though there's supposed to be 2, there's only 1 on this type of equation. So you'll find that you'll always have 2 answers for quadratics. You might have 2 of the same real answer. You might have 2 of the same answer. Or I'm sorry, 2 of the same real answer, 2 different answers, or you'll have 2 imaginary answers. We'll talk about that later, okay? But that's how you do numbers 1 and 2. Questions on 1 or 2? Okay, so I want to spend time with you discussing it. So on number 1, I'm going to go back to number 1. 1's till the 2 is how I do number 1. I'm going to press play, and as it goes, I want you to explain what I'm doing to your neighbors. So 1's tell the 2's. Actually, let's have today's Tuesday. 2's are talking first. 2's tell the 1's about number 1. Explain the whole thing, including the zero product property. And then when that's done, 1's will talk about number 2. Okay, go. 2's are talking. What's going on? Go. Number 3. So, just to make sure, what happens if there's a, what happens if the original problem has a y here? What would you do if there was a y there? Make it a 0, okay? So, if there's a y there, just turn the y into a 0, right? Because we're trying to find where y is equal to 0, okay? Write the problem down, let's go. We're doing this one together. We're doing number 3 together. Okay, so question, is everything moved over to one side of the equation? Yes or no? Good, okay, so what's your A, B, and C? A, B, and C, come on. Doing this together. Okay, good. So we're going to create an X box, right, with 1, negative 2, negative 15. 1 times negative 15 is negative 15. B is negative 2. Okay, what multiplies to be negative 15 but adds up to negative 2? Negative 5 and 3, okay. Doesn't matter what order you do that. Can I simplify these fractions in my X box? No. And tonight you shouldn't be able to simplify anything. Tomorrow we'll do more complex ones, okay? Alright, so we're going to rewrite this now as r plus 3 and r minus 5 is equal to 0. Alright, turn to your neighbor and tell him what property you would use next. And explain how would you apply it here. Explain what you would write. Okay, what's the property we're going to use, everyone? Zero product property. What am I going to write? Someone tell me. Good. R plus 3 equals 0 and R minus 5 equals 0. Good. Finish up my problem for me. I'll give you 15 seconds. Go. So that's right. The answer is R is equal to negative 3 and R is equal to 5. Make sense? Okay, good. Most of you got that. Raise your hand if you made a mistake on the signs. Okay, good. Number 4. Can we use Xbox in number 4?
No.
Yeah, we can. What's B equal to? What's B equal to? 0, right? But what kind of form is this to factor? Difference of squares. What is it, everyone? Good. So you should be writing n plus 4 times n minus 4 is equal to 0. Finish up my problem, please. Go. So your two answers are, listen up, n is equal to positive and negative 4. Okay? Here's a couple ways you could write it. You could write n is equal to positive 4 and n is equal to negative 4. Or you could write it like this, n is equal to plus minus 4. You see this? That's a notation that you should get familiar with. Raise your hand if you've seen the plus minus sign before. Okay? Feel free to use that. And this last one is set notation. Okay? That means the answers to the set are negative 4 and 4. It looks like parentheses with a little point at the end of them. Okay? Got it? Okay, good. Next one, number 5. Turn to your neighbor and tell them what you would do first on number 5 before you start. Okay, someone raise your hand. What would you do first? Yes, David.
Subtract 5.
Subtract 5. Why would you subtract 5, David?
To get a 0 and everything on one side.
Good. Okay, so that's what we're all doing first, right? So your problem should start off looking like this, okay? Finish up the problem by yourself. I'll give you about a minute. Go. Okay, so the answer here is, you do your Xbox, right? So n is equal to, raise your hand if you put 4 and 5. Positive 4 and positive 5. Is this correct? Do you just copy these numbers from 4 and 5 down here?
No.
No. Why not? Because it's wrong. Exactly. It's wrong. Good. That's right. It's totally wrong. That's good. Okay, n plus 4 and n plus 5, right? You have to change these to be two binomials, right? And then when you solve it using what property? Zero product property. You got to subtract 4 and 5, and then you get n is equal to negative 4 and n is equal to negative 5. Raise your hand if you accidentally put 4 and 5. Accidentally. Okay, some of you did, so I won't call you out. But that's how you do number 5. Number 6 by yourself all the way through. Go. Here's the answer number 6, okay? Negative 4 and negative 2. All right, that concludes our lesson.